Hello students, Professor Benavides here. Let's talk about Chapter 8, Functions. Specifically, let's drill down on passing arbitrary number of arguments. So, does Python allow a function to collect an arbitrary number of arguments from the calling statements? Yes. Sometimes you won't know ahead of time how many arguments a function needs to accept. Fortunately, Python allows a function to collect an arbitrary number of arguments from the calling statement. For example, consider a function that builds a pizza. It needs to accept a number of toppings, but you can't know ahead of time how many toppings a person will want. The function in the following example has one parameter, asterisk toppings. But this parameter collects as many arguments as the calling line provides. So let's go ahead and take a look at this. Here's the function definition on line 2. Notice I can expand and collapse it there. I'm using Sublime. And this function has one parameter, but it takes an arbitrary number of arguments. What allows us to do that is we're putting an asterisk in front of the key in front of the word toppings. Now this is going to create an empty tuple. Okay, so that we're going to go ahead and print the list of toppings that have been requested. And when we print this, we're doing this specifically to show that this is, let me go ahead and run it, so that this is a, you'll see it's in parenthesis. The first time it's called on line 6, I pass only one argument, pepperoni. It goes into the tuple anyway. Notice how it's enclosed in parentheses. So the idea here is it doesn't matter whether it's 1, 2, 3, or whatever, it's going to put them in a tuple, right? And that, remember that is signified by the opening and closing parentheses. Okay. So the first time I pass one argument, the second time I pass 3 arguments, and those 3 arguments go into toppings, and then we print toppings, and that's why we end up with mushrooms, green peppers, and extra cheese. Okay, so the asterisk in the parameter name asterisk toppings tells Python to make an empty tuple called toppings and pack whatever values it receives into this tuple. The print call in the function body produces output showing that Python can handle a function call with 1 value and a call with 3 values. It treats the different calls similarly. Note that Python packs the arguments into a tuple. I know I'm repeating this because it's really important, even if the function receives only 1 value. That's where we get this output pepperoni, and it's got the comma on there. It only has 1 value. So now what we're going to do is we're going to take it up a notch, and we're going to replace the print call with a loop that runs through the list of toppings and describes the pizza being ordered. So let's look at the next example on here. I'm going to go ahead and run it. So basically this is the same as the one before, except we're using a for loop. And before we just simply printed the tuple, right? In this one here, we're looping through it, each one, and then we're printing each topping in toppings. So the first time we pass pepperoni, we get this time we get the ability to have a customized statement. We say making a pizza with the following toppings, and so then we end up with the first time we end up saying making it, getting the output, making a pizza with the following toppings: pepperoni, making a pizza with the following topics: mushrooms, green peppers, and extra cheese. Okay, the function responds appropriately. Whether it receives 1 value or 3 values, the syntax works no matter how many arguments the function receives. Okay, so that was an introduction, and we are only dealing with, one situation. Let's kick it up a notch, and let's talk about mixing positional and arbitrary arguments. Let's go on to the next one on here. Let me go ahead and run it so the output doesn't confuse you. maybe I should go over the code first. And I embellished this a little bit. So let's go ahead and take a quick look at it. So how can you mix positional and arbitrary arguments? If you want a function to accept several different kinds of arguments, the parameter that accepts an arbitrary number of arguments must be placed last in the function definition. Python matches positional and keyword arguments first, and then collects any remaining arguments in the final parameter. For example, if the function needs to take in a size for the pizza, that parameter must come before the parameter asterisk toppings. So in this situation here, we'll also talk about Asterisk Args, and you'll often see a generic parameter called Asterisk Args, which collects an arbitrary positional arguments like this. So what I did was I copied the function and just called it pizza2 so that we could go ahead and see how in the first one I used asterisk toppings, and in the second one I did asterisk args. This is what's referred to as a generic parameter. Personally, I don't like generic parameters. I think you should give it a specific name according to whatever it is that you're dealing with. But apparently there may be times, I think maybe programmers think there's times where you may need to just go ahead and create a method that's, or excuse me, a function that's so generic that you can do something like this. So these two functions do exactly the same thing. One of them receives the, arbitrary, receives the arbitrary argument. And remember, it always should be second, right? Or last, excuse me. And in this particular case here on line 11, I'm using asterisk args. And of course, args stands for arguments, right? So it's kind of like like I said, it's just a generic parameter. It does exactly the same as before. I just don't like the print statement where he didn't give us an example of this. He just said, hey, some people use this. So I can imagine that when, the print statement would end up, if you're doing a loop, you'd say for arg in args. And that sounds kind of weird. I'd rather say for topping in toppings, But this, I guess if you create a generic function, it could go ahead and work for many different kinds of things. So apparently I would have to see the situation before I fully judge on this. So I call the first function once with 2 arguments and another time with several more. So the first argument goes into size, and the second argument, or from then on, the ones remaining will go into the tuple, right? So it'll take as many, as you throw at it, right? So when I run this, what I'm going to be doing is just proving here that when I call I got a new keyboard and I'm still getting used to it. I got a mechanical keyboard, a gamer's keyboard, and I'm still getting used to it. So let me just do a Control Z. I rested my hand on the keyboard and it gets very sensitive. Okay, so I was able to recover from that with a good old Control Z. All right, so I called the first function and then I called the second one only to prove that I'm getting the same effect. So let's go ahead and show that. So there it is, making a 16-inch pizza with one argument being passed into the tuple, or 3. Same thing again. The only difference is that the first function has a better defined parameter than the second one. The second one uses a generic parameter. Okay, so I think I've given you my opinion on that. So let's go on to talk about using an arbitrary keyword arguments. You can write a function that accepts as many key value pairs by calling by calling statements provided. So that, yeah, you can. So sometimes you want to accept an arbitrary number of arguments, but you won't know ahead of time what kind of information will be passed to the function. In this case, you can write a function that accepts as many key value pairs as the calling statement provides. Let's go ahead and take a look at an example here, and it's user profile. Let me go ahead and run it real fast so the output doesn't confuse you. So this this particular example builds on user profile. You know that you'll get information about a user, but you're not sure what kind of information you receive. The function build profile, in the functions here always takes in the first and last name, but accepts an arbitrary number of keyword arguments as well. Okay, so the definition of build profile expects a first and last name, and then it allows the user to pass as many name value pairs as they want. The double asterisk before the parameter user info causes Python to create an empty dictionary. So before we talked about an empty tuple with one asterisk. In this case, we're creating an empty dictionary called user info, and it packs whatever key value pairs it receives into this dictionary. Within the function, you can access key value pairs in the user info, just as you would any dictionary. Okay, so let's just go ahead. And here we're also using another generic parameter called KWArgs. And of course, that stands for keyword arguments. And I don't particularly care for them, but I wanted to go ahead and show you how they could possibly be used. He didn't give us an example in the book. He just made a little note. So I tried to go ahead and simulate that. So we're talking about arbitrary keyword arguments. In this case, 2 asterisks will give us an empty dictionary. So we're putting in first and last. These are positional, and then we have our key value, pairs here. I copy this function and call it profile2. And the only thing I do to change here is I give it this generic parameter name of keyword args. All right. So I call on line 18, I will call build profile, which is defined on line 5, and I'll pass Albert Einstein, location Princeton, field physics. Okay. And then on line 22, I print user profile. Okay, so when you call build profile, the flow of control is going to leave line 18 and it's going to go to line 5, and it's going to put Albert in first, Einstein in second, and it's going to put location, Princeton location, and physics field or field physics inside of the empty dictionary. And what happens here on lines 7, 8, and 9 is that you end up building the dictionary. You end up having first name, last name, and then the things that are passed are location and field. Those are the keyword arguments. These are the keyword arguments that are being passed in. Okay. Then I go ahead and call it again. And the different situation that I have here is when I call the method, I don't assign it to a variable. I don't particularly like this style. I know a lot of students like to do this. You see, let's compare them. So line 24 and line 28, they end up producing the same output. But what happens on line 18 is I call the function. I pass it Albert Einstein and 2 keyword, combinations, right, to build my dictionary. The dictionary is then returned from line 9. The dictionary is built with that information, and it's returned right here. And that return is then assigned to user profile. So user profile is a dictionary that I print. So if you don't want to assign it to a variable, which is, I do believe this is the way to go, this is the way I do it. Some people will simply say, you know what, I don't need the variable. I'm not going to use it anywhere. So they just call the method. They pass whatever they need to pass. The return will pop in right in here and be printed. So you end up with, run it again, you end up with exactly the same output. Those are two different styles. Hopefully I am convincing you that line 24 is the better way to go, but there are people who code like line 28. The other things that I do here is, remember, I'm using this generic keyword, which I don't like, versus a descriptive name for the dictionary, user info. So that's the end of this section here. Let's go ahead and talk about the try it yourselves. And these are quite simple here. 8.12, it's the title is Sandwiches. It says write a function that accepts a list of items a person wants on a sandwich. The function should have one parameter that collects as many items as the function call provides, and it should print a summary of the sandwich that's being ordered. Call the function 3 times using different number of arguments each time. Okay, so let's go ahead and take a look at that. So here's my function definition on line 4. So asterisk items creates a tuple, right? And it is, let me go ahead and run that. So what happens here is I call it 3 times on line 12, 13, and 14 with a different number of arguments each time. Okay, so I pass it 1, 2, 3, 4, 1, 2, 3, and then 1, 2, 3 different number of arguments. So that goes to show that this function will accept an arbitrary number of arguments. And in this case, it's going to go ahead and put it in a list. And actually, that list is going to be a tuple. And we're going to go ahead and then loop through the items in that list. The loop starts on line 7, and it says for item in items. Yeah, it takes a long time to think about the singular plural. I mean, I've had a hard time coming from other languages, coming from C++ or Java. We used like I a lot for index. I may have done that in a demo in the past. So if I have, forgive me. I'm trying to get that out of the system. If I see you doing that, I will alert you to it, because it's not the style that we should be using on here. Okay, so I call the function 3 times, and the function simply loops through the items in the list and returns, or in the tuple, and shows them on the screen. Okay, here's the next one on here. Here you start with a copy of the user profile from page 149, and it just says build a profile of yourself by calling build profile, use your first and last name and 3 other key value pairs that describe you. So I mean, it sounded like I just did a copy and paste of the other one, and I changed, instead of Albert Einstein, I put Robert Benavides, and then location I put Plano, I put my field computer science, and I just added an extra. I didn't know what to put, so I just put age gets 65. So when I run this, you'll notice that I'm using 2 asterisks here. So this is going to end up creating a dictionary. And we see on my output here, we're not looping through it. See, when you loop through it, it's kind of hard, not hard, but the reason why he prints out the dictionary is to just verify to you that, hey, you use 1 asterisk, you get, the tuple, you use 2 asterisks, you get the dictionary. But when you can't really see that when you loop through the items. So what do I have here? Line 4, I have my function definition. On line 10, I have my call. And remember, you can call it, and the return will then be placed in user profile. So when I say print user profile, it is printing what? it is printing the dictionary, right? Of course, I could have just said print and then just put build profiles and then pass it all this stuff, and I would have ended up getting the same output. Last one on here, it's 8.14 called cars. It says write a function that stores information about a car in a dictionary. The function should always receive a manufacturer and a model name, and it should then accept an arbitrary number of keyword arguments called the function with the required information and two other name value pairs such as color or an optional feature. So let's go ahead and take a look at this. Let me go ahead and run it. Did I modify this? Let me see. No, I don't think I did. So function always receives the manufacturer and the model. So we've got that. So positional values are okay. The last one in this particular case, we're going to end up building a dictionary, right? Because we got two asterisks, but also receives an arbitrary number of key value arguments. So what we do here is we build a dictionary, we get manufacturer, and we put that into manufacturer, we get the model, we put that in the model, and look at this, we're using the title method. Then we use a loop, and the loop says for option comma value, and those are kind of, you know, allows us to traverse the dictionary in options.items. So in that particular case, we're assigning value to option in the dictionary, right? Then we return the car underscore dic, and that is then returned on line 16. Okay, so on line 16, I call the function. Flow of control leaves and goes to line 5. It goes into and does all this and returns the dictionary. I come back to line 16, and that dictionary is assigned to my Outback. That's a cute name because that's his Subaru, right? You always, you always have to come up with a good name. You know, I mean, certainly he could have put my first car, my second car, but these are really, he's used, we want to copy the style that the author does, really good names. 1991, he's got a 1991 Honda Accord. Probably that is old, right? But they say they last a long time, right? Or especially the ones from a long time ago. I don't know about the new ones anymore. So he calls this dictionary my old Accord. So the output then, is shown below for that second call. And that's the end of this section. So to summarize, we talked about passing an arbitrary number of arguments. We first started off with a simple introduction of passing one, of a function that has one parameter that takes an arbitrary number of arguments. And then we talked about mixing positional and arbitrary arguments. Remember, the idea is you have positional and arbitrary arguments. The arbitrary arguments must be last. And then we also talked about using arbitrary keywords, the key value pairs that are used in the creation of, say, for example, a dictionary. And in this case, again, if we have to comply with those rules that positional parameters should appear first, and then last, we would then have the arbitrary keyword parameter. And in this case, we're using two asterisks to create or to work with a dictionary, or for that matter, one asterisk to work with a tuple. So it's important to understand the difference between the one asterisk and the two asterisks and what you're getting there. This section also talked about using these generic parameter names, which I told you that I particularly didn't like, but he just says you'll often see the generic parameter name asterisk ARGS. Remember I said that stands for arguments, which collects arbitrary positional arguments like this. Well, I'd rather you use a distinctive name for your variables, lists, tuples, dictionaries. I think it increases the readability of your code and makes it much easier to understand. The other parameter, generic parameter that we used was the KWARGS. He says that you'll often find these parameters. So I guess it's like people use these, but it doesn't sound like he's not promoting them. He's just saying, hey, you'll find them, that some people will use them in the code. So we need to be aware of that when we see that. But other than that, that's all I have to say about this section. I'll see you in the next. Thank you very much. Goodbye.